you know how numbers, they might be confusing and you want to estimate and find an easier way to find out about how much the answer is going to be. So first I'm going to talk to you about what's called front end estimation. Alright, and what that is when you have a couple numbers, say you have 1,219 plus 3,421, and you're going to estimate what that is using just the front numbers there. So what would you estimate that is? 4,000. Okay. So, if you have, for example, this problem, which is 5,024 minus 1,019 minus 2,711. What would that be? 2 what? 2,000. Okay. So then I'll show you one more problem. So then if you had 2,473 plus 1,142 plus 4,901, I'm going to add the 2, the 1, the 4. 7,000. Okay. So yeah, that's just an easy way to kind of estimate around what your answer is going to be. So I'm going to want you to solve these problems on your own. You can use the paper that I've used for you if you need it. Yep, we're still just doing the front end estimation here. Okay. So what did you get for, oh yeah, I'll give you a minute to do.
10,000.
This one you got 10,000. And what about the subtraction problem?
5,000.
5,000. Alright. So even though this will give you a rough idea of what your answer is going to be around, why is this method maybe not as accurate as other ones?
Because you're still missing the hundreds.
The hundreds and the tens and the
The
ones.
ones.
Yep. That is correct. Which will take us to our next strategy for estimation, which is rounding. So, say you're going to round these numbers here. So if this number is 4 or lower, you round down. And if the number after it is 5 or above, you round up. So, if you 500. Okay. So, yeah, and that's kind of, with this particular problem, it looks almost like front-end estimation, but really you're rounding using the tens place in those problems. So, what about if you had 693 minus 436? What would this be rounded to?
700.
And what would this be rounded to?
400.
400. So what would you estimate the number to be? 300.
300.
Alright. So now we'll use some larger problems. 1,897. 3,219. So what would you estimate this number to be at? We're going to go up to, we're going to be rounding to the nearest thousands.
5,000.
Oh, the whole problem is 5, okay. Whole problem is 5,000. Because this would be 2,000, and that would be 3. Okay. So, the problem that I had you do on your own earlier was 3,723, 4,912, 3,817. We estimated that to be around 10,000. So now, if you round, what is this number going to be rounded to?
4,000.
We have 4,000. And what about that number?
5,000.
5,000. And this number?
4,000.
Alright. So if you add all of these numbers, then what answer do you get?
13,000.
13,000. So you can see how rounding might be a little more accurate or help you find how big of a difference between the two numbers you're going to find. Because when you use front-end estimation, your answer is going to normally be either equal to or less than what the actual problem is. But if you round, your answer can be a lot more. Okay, so I want you to do this problem on your own.
It's 2,000.
Alright, so that will be roughly around 2,000, so you know if you do the actual subtraction, you end up with 24,000, that you're nowhere near what the answer should probably be. So when you're rounding, what's another way that you can round to be more accurate, such as the first problem I showed you, which was 219 plus 347. Say, for instance, you want to round to the nearest 50, just to make it easier to add. So 219 would round down to 200, but 347 would be rounded to 350. So then you know your answer is going to actually be closer to 550 as opposed to 500. So if you have 741 plus 243, what can you round 741 to?
750.
And what about 243?
250.
Okay. So what's 750 plus 250?
1,000.
1,000. Alright. So then when you round to these 50s here, we can call those compatible numbers because you change the numbers into something that is a little more, which is a little easier to work with because it's sometimes easier to round to the nearest 50 as opposed to the nearest 100 when you're already in the 40s, or say if this was 263. It'll give you a little bit more of an accurate estimation with your problems. Alright, so I'm going to show you one more strategies such as if you're multiplying, which we call clustering of numbers. So I'm going to apologize for your humor. Okay. So what number are these 5 numbers close to?
200.
200. And how many different numbers are there?
5.
So we have 1, 2, 3, 4, and 5.
Yeah.
So what's 200 times 5?
1,000.
1,000. So if you were told to multiply all these numbers, then you would easily be able to estimate, oh, they're all close to 200, so 200 times 5 numbers, you know your number is going to be around 1,000. So let's try this one. Oops, that shouldn't be there. Okay, so what number are all of these close to?
1,000.
1,000.
The shredder.
And how many numbers are there?
5.
Alright, so what is 1,000 times 5?
5,000.
5,000. Alright. That kind of looks like 2. Alright. So clustering of numbers, you can do it whether there's 2 numbers, or 3 numbers, or 9 numbers. But these are some different methods that we can use for estimating numbers to help give you a more accurate estimation of what the actual answer is going to be. Do you have any questions about any of the front end estimation, rounding, or clustering?
No, ma'am.
Okay.